Good day to all and welcome to this online course. In this first module, we will conduct an overview of the principles of breaking electrical circuits, produced by Zenzel Automation in collaboration with Hydro-Quebec. Goals of this module. At the end of this module, the participant will be able to describe the principles of breaking a circuit and relate them to the speed of circuit breakers. Lesson 2, Auxiliary Contacts. What are the types of auxiliary contacts? What is the role of each type of contact? What are the types of auxiliary contacts? To answer this question, let's first see the following electrical schematics. A simple circuit breaker is represented only by a main contact. A circuit breaker with a pre-insertion resistor is made of a main contact in parallel with a contact followed by an insertion resistor. In addition, we have signal contacts in the control cabinet. The pre-insertion contacts and the signal contacts are both commonly called auxiliary contacts. It is important to know the difference between them. The following animation explains the role of the pre-insertion on opening. At the beginning, the main contact is closed while the pre-insertion contact is open. Note that the resistance is 0, so the current flow is at its maximum. The first stage is the closing of the pre-insertion contact. This connects the insertion resistance while keeping the main contact closed. The second stage is the opening of the main contact. The current then flows through the resistive contact, and we note a half deflection caused by the insertion resistance. The third stage is the opening of the pre-insertion contact. Another half deflection is caused by the opening of this. The circuit being open, resistance is infinite, and the circuit is completely open. This manner of operating the pre-insertion contacts limits overvoltages during the opening of circuit breakers. They are required in the case of inductive circuits such as transformer coils. The following animation explains the role of the pre-insertion on closing. At the start, the main contact is open while the pre-insertion contact is also open. Note the infinite resistance value and the zero current flow. The first step is to close the pre-insertion contact. A half deflection, caused by the insertion resistor, appears. The current begins to flow, limited by the insertion resistor. The second step is to close the main contact. Another half deflection appears, proving that the current is fully restored. The third step is to open the pre-insertion contact. This manner of operating the pre-insertion contacts limits the current overloads when circuit breakers are closed. They are required in the case of capacitive circuits, such as capacitor banks or long, unloaded lines. The second type of auxiliary contacts are signal contacts, commonly known as 52A and 52B. They allow us to know the state of the breaker. The 52A contacts follow the state of the main contacts. They are open when the breaker is open and closed when it is closed. The 52B contacts have the reverse state of the 52A contacts. They are required to command or interlock closing or opening operations. Indeed, they are a part of a signal contact block linked to the breaker's command mechanism and are operated at the same time as the breaker. Question Lesson 2. What is the role of the pre-insertion contacts when a circuit breaker closes? A. Limiting current overloads. B. Limiting overvoltages. C. Raising line voltage. D. Do not serve any purpose. The correct answer is A. Limiting current overloads.